This course is on Power System Analysis and Stability. Module 2, Formation of Network Matrices. So about the introduction in Module 2, the various terms used in graph theory are presented in this chapter. Formulation of different network matrices are discussed. Primitive impedance and admittance matrices are explained. And this chapter also deals with the formulation of Y-bus. So first we will deal about the bus admittance matrix. So the bus admittance matrix, it's a square matrix and it has n number of buses, and the size of the matrix is n by n. The diagonal element represents the self or short circuit driving point admittances with respect to each bus. The off-diagonal elements or the short circuit transfer admittances, the admittance common between any two numbers of buses. So in other words, the diagonal elements Yii of the bus, Y bus, is the total admittance value with respect to ith bus, and Yik is the value of the admittance that is present between ith and kth buses. So the bus admittance matrix can be formed with the following methods. Number 1 is direct inspection method, 2 step-by-step procedure method, 3 singular transformation method, and the fourth one is non-singular transformation method. So the important definitions in graph theory before going into the Y-bus formation by inspection method or any of the method. So these are the important terms we have to know about it. So what is a graph? A graph shows a geometrical interconnection of elements of the network. And what is a subgraph is? It is any subset of elements of a graph. What is a path? Path is a subgraph of connected element with not more than two elements connected to any one node. So a graph is connected if and only if there is a path between every pair of nodes. If each element of the connected graph is connected in a direction, that it's an oriented graph. So if you see these important terms about the graph, a tree, one more term is tree. So what is a tree? Is connected subgraph of a connected graph having all the nodes of the graph but without any closed path. That is, there is no closed loop. So the elements of the tree are called tree branches or twigs and are denoted by thick lines. So the branches of tree are called twigs, and the branches of tree not in the tree is called links. So here the twigs are connected by dark lines, and the links are connected as like dotted lines. So here the first picture given the graph of a network which connected between 1 to 3 or the nodes, and the branches are connected. The same network can be represented in this graph is about. So there are 3 branches, 3 nodes, 1, 2, 3, and 1 is in reference node. So what are the connections? It is given here. As per the tree, we have to draw a branches. It contains all the nodes, but the branches will be not forming any loops. So I will connect the twigs, that is branches of tree, between 1 to 3, 1 to 0, 0 to 2. The remaining branches are called links. And what are the basic loops and fundamental loops? Here the loops which contain only one link or independent are called basic loops. In other words, wherever a link element is added to the existing tree, basic loops or fundamental loops can be obtained. So the number of fundamental loops is equal to the number of links. Here it is explained, and whatever the tree in the last slide, it is explained here. And the basic cut set or the fundamental cut set, a cut set is a set of elements that is removed, divides the connected subgraphs. In other words, a basic or fundamental cut set of a graph is a set of elements considered of only one branches or the twigs and minimal number of links is or chords. Number of basic cutsets are number of ticks. Thank you.